So mostly these are what we're talking about. Now, of course, they're going to get a little bit more interesting than this. But this is a good thing to remember about what's going on. What would the answer to this be?
X equals 9.
X equals 9. Is that okay with everybody? Why is that okay? All right, and I like the way you describe that because it is important to plug these answers in. So the square root of 9 is 3. So if we're thinking of solving equations, we usually do inverse operations. Right? Does that make sense to say? Yeah, so the inverse operation of square rooting then must be squaring. Now, of course, that's unfair because that was part of my notes. Not that it's unfair, but I don't know that you knew that before you read my notes. All right, so for the most part, that's all we're doing. But you do want to check these because we do have to deal with something called extraneous solutions. Does anyone remember what an extraneous solution is? So I don't know the real definition, but the best way to think of it is that you've done the equation correctly, and then when you plug in the answer that you got, it doesn't work. So it's not really an answer. Okay? So occasionally these happen, especially when you're messing with exponents. So we do have to check these. Of course, this one's obvious because that's how you guys figured it out. But the important thing is that the inverse operation of squaring is square rooting. So when you think of inverse operations, you're either doing an inverse operation to every term, and that would be like multiplying and dividing, or you're doing it to each side, which is how you add and subtract. So one thing that you want to keep in mind on here when you're doing these is that when you square or square root, when you mess with exponents, you have to do it to each side. So that explains the reason that the first step is to get the radical term by itself. Because you want to, when you square, you want to do the least amount of work as possible. So on this problem, do we have the radical term by itself on one side? Okay, so we want to do that first, and so then how would we do that? Add 2. And later on you'll understand why this is so important to have it. Because again, if you're squaring, you have to square the whole side. So now we do have the radical by itself on one side, and so now we can square. Remember, you're squaring whole sides here.
1/5 equals 2x minus 7.
Is that okay with everybody? Right? When you square a square root, the only thing that happens is they cancel themselves out. That's the nature of an inverse operation, and you're just left with what's inside. Okay, yeah, so the third step said if there's no more radicals, just solve the equation, which is a hint to what's to come, because sometimes after that step you'll have a radical. But what's 25 plus 7?
32.
32 equals 2x,
Divided by 2.
so x must equal.
16.
Okay, now, it's always a good idea to check your answer by plugging it in. But you need to make sure you do that on these problems because of this situation of extraneous solutions. There is a chance that what we just did, which is correct, we solved it, our steps were correct, we computed correctly. Maybe when we plug this back in, it's no longer true. Okay, so you do need to check on these. So let's plug it in. So go back to the original 3 equals the square root of 2 times 16 minus 7. Minus 2. So now we're just checking for a true statement. So what's 2 times 16?
32.
All right, so I'm running out of room here, but can we all agree that the square root of 25 is 5 and 5 minus 2 is 3, and so we're happy? Okay, so then yes, this is the solution. Not only did we do it right, but it is what we were looking for. Is that okay? Okay, so I'm just following the steps. Do we have a single radical term on one side of the equation by itself? Yes, we do, right? It just so happens that each side has a single radical term. But it doesn't matter what you start with. You need to manipulate the equation so that one side has only one term with the radical. All right, so we do have that. Is that okay with everybody? So then what's the next step?
Square 'em.
Square them. Uh-oh, what happened? All right, so then when we square a square root, what happens?
They cancel out.
So then what's on the left-hand side?
X minus 5.
Right-hand side?
4x minus 29.
Is there any more radicals left in this equation? All right, so then we just solve it. So how do we solve it? Add 5, okay. So now we have x equals 4x minus 24.
Yep. Subtract that. Alright, let me-
So then x equals,
Eight.
is that okay? All right, nice easy stuff. But we better check. So you gotta go back to the original. And you're just looking to see if these are true. So a minus 5 is 3, so square root of 3, what's 4 times 8?
32.
What's 32 minus 29?
30.
So we have a solution?
Yep.
How's that? Now you should be feeling pretty good, right? This stuff isn't so bad. Okay, so what?
First thing first, radical by itself.
Okay, so
From each side.
now we have the fourth root of 3x minus 5 equals 7. Now squaring won't take care of us anymore.
Nope.
Why?
Because it's the fourth.
So it's the fourth root now. So then when you're messing with your exponents, you're doing it each side. So what should we raise each side to?
Fourth.
To the fourth power, all right. So what happens on the left-hand side?
Cancel out.
What about the right-hand side?
3,401.
Exponential growth, Dave. That's why we're all here. You know? That's why we're all of us. You might be here without exponential growth, but all of us wouldn't be here without exponential growth. Add 5, so 3x equals,
Divide by 3.
so then x equals,
8.
all right, so again, we better check. We need to know. So what's what's 3 times 802? And then we subtract 5, so we have the 4th root of 2401. Fourth root of 2401 is
7.
that a true statement? All right, then we can accept it. We doing okay? I'd like to rewrite the left-hand side in the exponential form. Right now it's in the radical form. So who remembers how to switch the form? Who remembers how to switch the form? I'll give you a hint. Well, you'll help me with the hint. What is this stuff raised to?
4.
No. Just the inside part. To the first, okay. So if I wanted to rewrite this without a radical, it would be to the what? 1/4, thank you. All right, but the way to solve it is still the same. We would raise each side to the 4th power. Okay, and I'm redoing this to help you think about what you're really doing right here. So how is this number and this number related?
I'm very confused why that 4 is on the outside of the bracket.
Well, I should have it on both sides, shouldn't I? Thank you. There. Sorry. Right? Because that's how you would solve it, right? We just did this problem and we decided that we're allowed to raise it to the 4th power, which was true. Thank you, though, for finding that for me. But how are these two related?
Maybe walk over and do 1.
Yeah, okay, so when we multiply them together, we get 1, which is why, the next step would be 3x minus 5 equals 7. So, but I want to concentrate just on the fact that when you multiply these things together, you get 1. There's a word for that. But actually, there's a couple words for that. One of them I don't want to, I'm only looking for one of them, though. The one I don't want is that they're inverses of each other. Although I guess that one works too, but the other one begins with an R, and you did it when you were dividing fractions. Yeah, good, reciprocal. These are reciprocals of each other. Is that okay? So really, on my steps it says square, but really you're just raising each side to the reciprocal of the power. Is that okay with everybody? Okay, so then, it's just like we solved it. But what about these two problems then? Oops. Uh-oh.
What problem was the last one?
So then, right, that's supposed to be a 1/7. So what do we want to raise each side to? So then we raise both sides to the 7th. I don't know what's -3 to the 7th.
-2,187.
Does that make sense? Right, 1/7, the reciprocal of 1/7 is 7. Okay, this would be the same if it was the 7th root of x equals -3. So what about this other one? What are we raising this other one to? To the what? Not to the 2/5. Two-fifths would be what we add to 3/5 to get 1. But we don't want that. We want that reciprocal.
5/3
So it'd be 5/3. Now nobody really knows what 1.728 to the 5/3 is. And so then that's why they created calculators. So I would make sure I could raise 1.728 to the 5/3. So everyone should play along and make sure that they can do it. Or don't and not understand later why you can't do it. What is it? Did they tell me wrong earlier?
2.4.
Yeah, they told me wrong. I should have checked them. What is it?
2.48832.
2.488.
883.
We'll just go to 883. They told me wrong. It's hard to check that. It's hard to raise a decimal to the 5th power and then find the 3rd root of it. In your head, that is. Not with the guy. All right, is that okay? Sorry, they make a shot for that now. All right, what's going on?
Add x to each side.
Yeah, we don't have the radical by itself, so let's add x to both sides. So then we have the square root of x plus 7 equals what?
1 plus x.
All right, so I'm going to write x plus 1, but that's the same thing. Now we have the situation we want, so we square them. All right, so then what do we have on the left-hand side?
Plus 7.
And what do we have on the right-hand side?
X squared 1.
No, I don't think so. What is it?
X squared 1. Plus 1.
Oh, x squared plus 1. No, not that. What do you do? When you're squaring, what does that mean to do?
Multiply it by itself.
Guys, how do you multiply these things by itself? Yeah, you better FOIL, right? X plus 1 and x plus 1. So when you do that, what do you get? X squared
Plus 1x.
plus x.
Plus 1.
Plus what?
1x.
All right, so then really, it's x squared. So we're on the 3rd step now. It says if there's no radical term, then we just solve the equation. So how do we go about solving this? How do we do it? You guys just took a quiz on it, I think yesterday. All right, subtract 7. So x equals x squared plus 2x minus 6. Subtract x, so 0 equals x squared plus x minus 6.
What did you write right there? Does that say plus 2x?
Yeah, it says plus 2x. I couldn't pull my pen high enough off the screen. I'm running low on calories. Need another Tic Tac. Be able to do it. It's way over there. Tyler needs me close. I'll walk away and just fall down. So how do we do this?
Add 60 each side.
No, you're crazy. Crazy kid up there. Why'd we do all that work to get a set equal to 0?
Now you gotta. Now give it to 0.
Yeah, now you gotta go 2 and 6, x, right?
Yeah, so, oh yeah, right, so
So we
we're,
go x2 plus 3x minus 2x minus 6.
okay, and so we did that to do, so what, alright, so then, what do you take out of the first two?
X. Plus 3. So when you take out -2, you'll be at +3. So x equals -3 and positive.
You didn't think you were done with that stuff, did you? Oops, sorry. You didn't think it was all gone. Alright, so we do need to check for extraneous solutions. I'm gonna run out of room here. Unless I can write really small, but I don't think I'll be able to. Because this is usually when an extraneous solution shows up. What's that clock say back there? Still nothing? Alright, we're only on the third week. I'm sure they'll fix it something. 11? Oh, do we gotta hustle? Oh, we gotta hustle. Alright, so I'm just gonna tell you. When you plug this one in, it doesn't work. And then when you plug this one in, it does work.
So that's our answer.
And so that's our answer. So is there any questions on this?